Welcome to the Solarcoaster, a podcast about the ups and downs of the Australian solar industry, brought to you by the technical team at Supply Partners, with host Wade Allen and technical guru Andrew Thompson.
Thank you for your time today and for joining us here on the Solarcoaster podcast, brought to you by Supply Partners. We are a 100% Australian-owned and operated national distributor of solar and energy storage equipment. We are not just box movers, but we bring you technical and sales support to help you and your company stay educated, informed, competitive, and hopefully profitable. All the meanwhile staying in the cart on this always exciting ride we call the Australian solar industry. I am your host, Wade Allen, and with me, as always, our local technical guru here at Supply Partners, Andrew Thompson. AT, how are you today?
I'm pumped.
Yeah, attaboy. Yeah. Nice, I love it. And today we have a guest that has traveled great distances to be with us today. Over land and sea, nothing was holding him back from being with us today. The owner, co-founder, CEO of AERL, Mr. Peter Watkinson. I almost said Wilkinson. Watkinson, how are you today, sir?
I'm very good, thank you, Wade.
It's great to have you here.
Yeah,
Thanks for making the trip.
It was a great effort, really was.
Yeah, we appreciate it. We appreciate it. And for those who don't know Peter, he actually comes from Australian solar royalty, do you not? Yes.
Something like that.
Yeah, well, your father, Stuart, he founded AERL when, 85?
Technically 84. Yeah.
84.
Yeah.
And he developed the power optimizer, which became the maximizer?
Yeah, so basically the first iteration of something that went on to become the MPPT, or the maximum power point tracker.
That's incredible. This is all before you were even born.
Oh yeah. I well and truly didn't exist at this point in time.
Yeah, well, he had other plans at that time. But even though you weren't around, can you give us a little backstory on how it all came about?
Yeah, so basically graduated uni, and then he was doing some stuff with, of all things, a solar bike project, and he kind of wanted to find a better way of, so it was basically a little tandem bike that had a battery and a solar panel on it.
Okay.
And he was being a bit lazy, right, and didn't quite want to do as much work, so he tried to come up with a way of actually extracting the most power out of his little tandem bike panel.
Like most geniuses do,
and,
hey?
Yeah, so find the path of least resistance, right? The lazy way forward. But yeah, he came up with a way of doing it and then built a little prototype for his solar bike and thought, hang on, actually, this has kind of wider implications.
Yeah, right.
And then he sort of, worked on that a bit and eventually decided to try and commercialize it and start a little company out of his parents' garage, much to their displeasure. But yeah, so that was, and then it sort of just really went from there. In the early days, it was all just developing. The industry practically didn't exist back then, right? You know, we're talking about less than 80-watt panels that cost an exorbitant amount of money. So having something that effectively could help you extract 20 to 30% more out of your panels suddenly changed the economics of these systems drastically overnight.
Yeah, right. How does the MPPT actually work? What is it doing?
It's basically, the reason it was called the maximizer or the power optimizer in the beginning is because it effectively, and the company's slogan back in the beginning was for the perfect match, right?
Okay.
And basically what it's doing is it's matching the potential of your solar array, finding that maximum power point, and then converting through a high efficiency DC to DC conversion to your battery voltage. So it's basically finding the optimal throughput from the panel to your battery.
Okay.
So basically maximizing your power output of your array. So that's what it's doing, and now that same approach is in every inverter, every charger, every PV connected charger on the planet, right? That's just the way it's done, because you get the most out of your solar.
And he just kept reiterating the same thing over and over? Or did he come up with different products?
In the first couple of years, it was just all about battery charging stuff, and then he did some solar pumping, connecting PV arrays directly to DC motors and things like that. But yeah, it was predominantly the battery stuff because there just wasn't a good solution for it at the time.
Okay.
And then, it's some of the a lot of the early stuff was with Department of US Energy, US Department of Energy, and BP, and those sort of companies that were sort of trialing these on remote sites and things like that, but just needed a solution they didn't have.
Yeah, right. And then I'd imagine over time, as technology got better, componentry got smaller, everything, he was able to develop what's now the Coolmax.
Yeah,
right?
basically. So there was a couple of iterations. You had your first generation, which was the power optimizer, and then that became the maximizer, which for the real people who have been in the industry a long time will remember, like it has a triangular sort of polycarbonate front box on it.
Yeah.
You'll still see this. Some of them are still working, right? It's 30 years old and they're still running, which is crazy. But basically, that went to that, and then in the early 2000s, the Coolmax was born, basically, which was on the back of some new MOSFET technology that I forget the name of the company that developed it, but it was pretty groundbreaking, right? It allowed for a next leap forward in power electronics at the time. And what it meant is he was able to remove the heat sink, achieve really crazy efficiencies out of these things, and the product just ended up being basically a PCB, and that was it. And that the first generation Coolmax was basically a PCB in a box, and no heat sinks, nothing, and like 99.6% efficient or something absolutely crazy. So that's where the name Coolmax came from, basically.
Yeah,
was the fact that it was cool.
Right.
Very cool.
That's unbelievable.
I just have to say, I guess we're all here today, and the people who are listening are in the industry. So if it wasn't for what your dad did, and some of us might not be, the industry might not be as big as what it is today. So it's a massive contribution, and my family is supported ultimately by some of the advancements your dad made. So
yeah, no kidding.
Yeah, it's crazy stuff.
I've always said, because I don't know if you know this, but my dad's Australian, and he, throughout my whole childhood, always said, Aussies invented everything. He hangs his hat on it. He's like, we were the inventors of this, we were the inventors of that, and I've always been like, come on. But here's an actual story.
Yeah, well, and you can say that about almost the entirety of the solar industry. Current panel technology came out of UNSW. MPPT technology came out of Queensland.
Wi-Fi came out of the CSIRO.
Yeah,
or
exactly.
Similar. I mean, the bane of most installers of business.
That's right.
Still,
we probably shouldn't take no.
Yeah.
But yeah, that's like there's so much of the innovation comes out of here, and it's a cultural thing, right? Australians are just like, well, we see a problem, we try and work out a way to fix it. It's like we don't just sit on our hands and go, well, can't be done.
Yeah.
We go, okay, how do we get to the bottom of this, and how do we make this better? And that's all throughout Australian society, in every aspect of it. And that results in really innovative stuff, which is cool.
And unfortunately and sadly, like most, not like most, but like some geniuses and people who were taken well before their time, your dad passed away in 2008. How old were you?
I would have been 10 or 11 at the time.
Wow, that must have been just a whole change. What happened after that? What happened to the company? What happened to your family?
Yeah, it was pretty traumatic, actually, to be honest, as you imagine. I didn't, at the time, being a 10 or 11-year-old, you don't really process it until the later years. But it was because of it was directly as a result of his early work, right? So back in the 80s, the issues with lead solder and the conformal coating chemicals and all those, and copper etching materials and things like that, which are highly toxic, right, to the immune system, we just didn't know. And of course, he was doing that in his, he was making his own PCBs, he was soldering his own boards, all in his parents' garage. And they'd used to close the door on the garage because they didn't like the smell wafting upstairs.
Yeah.
And so he was doing that. And anyway, for a number of years, he was doing that. And effectively, that just really led to the health issues that he had later in life, unfortunately. And ultimately, him passing away. But we now know, we have really robust safety standards around that stuff now because we know it is toxic as hell. And in the electronics we produce today, most of that stuff's been pulled out. So we have much safer sort of working conditions around electronics. But, like in the early days of most industries, you don't know what you don't know. But yeah, it had a pretty significant impact on the company. He was the so many inventors, they never want to hand over the reins, right? So he was so crucial, right?
Yeah.
A lot of the designs and products and things like that, half of the intellectual property was still in his head.
Yeah, right.
So when it came to actually trying to get the company, trying to continue with the company after that, it was very difficult. And we ended up actually working with another Brisbane company called Tritium. But back then, they had, it was just the original founders still trying to work out where their little company was going to go. Mm-hmm. They hadn't really got onto the EV charging yet, or hadn't taken off yet, right? They were trying to make something of that.
Yeah.
Anyway, we ended up, basically, we ended up working with them to try and fill in the gaps in the intellectual property and the designs, work out, how these things actually worked. Because there was a lot in there that wasn't quite standard. There was a lot of designs he'd refined and come up with and things like that. So we worked with them, tried to reverse engineer the products and did successfully do so, and then was able to basically get something back to market, but it just, without Stuart driving the innovation and the engineering, it just, it wasn't the same, right? It was like Apple without Steve Jobs, right? Yeah. It's, in the early days. The current guy's doing all right. Yeah. But, it just floundered. So AERL sort of went into a deep slumber for a number of years.
Yep.
And then back in 2017, which is seeming like too long ago, for something that feels like yesterday, I had the opportunity, due to a couple of different circumstances at the time, to sort of kick it off again. I thought, what the hell, we'll give it a shot. The kind of like the general consensus around energy storage and the immediate impending need was really starting to build at this point in time. And I was just at uni, sort of kicking rocks. So I thought, what, let's see where this goes. And we relaunched AERL in late 2017, did a full rebrand, ground up restart, basically. And yeah.
So what, you were 20? 19?
19.
Wow.
Yeah.
Unreal.
Yeah. I wasn't doing anything that impressive back.
Yeah.
Yeah, I don't know. Looking back, it's like, was it youthful naive? Maybe youthfully naive,
it's a beautiful
or
thing.
just overly ambitious. I don't know. Anyway. But it was good. It was good. It was definitely a learning curve, because my background is not electrical engineering. My background is computer science. So I had to spend the first 2 or 3 years learning how everything worked, which was fun.
Yeah, you thrust yourself into it.
Just dive into the deep end and see where you end up, right, is generally the best way to do it.
I think that's probably worked to your credit, though, because any installer, anybody in the industry today tells you need to practically be an IT expert to work in this field.
That's right.
So,
It's led on to some of the stuff we're doing today, for sure, absolutely. But it's definitely, I do think hands-on practical experience is the best way to learn something. Or to really get a deep understanding of an area or a field. So it definitely was the right way to go. We do a lot with uni students these days, and when they come out of the unis, they have really good theoretical knowledge, but they're absolutely practically useless for the first two years or so.
Yeah.
And we spend a lot of time, teaching them the skills of how to actually, how to implement everything they've learned. So there's a lot there that you just can't get theoretically.
Well, you've probably got such a fresh take on this whole industry over people that have been in it for so long, and you're coming at it from more of an IT perspective. It's just no wonder why you're doing what you're doing and where you're going. Like your brain, like I know you pretty well now, your brain's quite fascinating. I love the way it works. It's, it's both a blessing and a curse for your brain to always be on.
Yeah.
You know, like sometimes you have trouble sleeping at night, or you can get pulled in different directions all the time. So what sort of like mechanisms do you apply to keep your focus? Like, because you must just see opportunity everywhere.
Yeah, it's I said to someone recently, like the biggest part of my role with AERL at the moment is just deciding what the hell we do next.
Yeah, okay.
Because it's genuinely like that. Because it is such an exciting and innovative space at the moment. There's so much happening in renewables. There's so many opportunities associated with that, and there's so many places where it's like, oh, we could do this, and that would be fantastic, and that would drive this area forward or this area. But we don't have unlimited resources. We have a really crack team, but I've got to actually pick what the hell they do. I can't say do everything, otherwise they probably would just leave. They'd head for the door. It is challenging to pick what to do next, but I think at this stage, just because I've done a lot of field installations and things like that, and actually really got to into the nitty-gritty stuff, that's kind of guiding, what actually are the most practical, urgent needs within the space.
Okay.
And so that's sort of leading us into the things.
So
we're doing at the moment.
when you finally hone in on that opportunity, what are your first steps as like a serial entrepreneur and someone who's driving this industry in a way? What are those first steps you take? Like what is it? What are the key things that you make sure that you put into every product that you innovate?
So the way we do it, right, is very probably backwards comparative to most companies, most legacy companies, right? If you want to launch a new product at an established company, you put together a proposal, and then it goes through all layers of bureaucracy and case studies and things like that before you can actually sort of do any hands-on stuff. The way we tend to do it, and this allows us to really move quite quickly, is that if someone has a good idea, they just go do it. And if one of the electrical guys wants to try a new circuit design, he's fully empowered basically to do that. Block out 3 days of his time, design it, do it, order it, prototype it, and build it. And then if it works and he's really excited about it, then we go, okay, how do we then utilize this? So we're sort of more set up to generate innovative ideas and then commercialize them, and just creating a culture and environment in the space that does that. So we don't. Yeah, it's very different. There's no major commercial case studies and things like that. It's just everyone's has a deep understanding of the space, and that allows them to make good decisions independently, and that's what we're really trying to do, is empower those that sort of sense of independence and responsibility.
Yeah, it sounds like a great place to work if that's how your brain works and that's what you want to be able to do. That's great. That's empowering your staff. You probably have good staff that want to stick around for sure.
We have good coffee too. Which
yeah. The recharge station, old Paulie, nailing it downstairs.
That's right. It's putting a cafe downstairs was probably the best thing I ever did.
I'm surprised how busy it gets in there.
There's no other cafes around. Yeah, that's right. Yeah. So
true.
It is good food and good coffee, though.
Yeah,
so I'll give it that.
Yeah.
Oh yeah.
So no, gets the job done.
So let's talk about the CoolMax. So you've redone it, the SRX.
Yes.
It's the new wall mount that's come out. And where have you improved this charge controller over the previous version?
Yeah, okay. So the biggest, for a long time now, there's been a huge amount of investment into Grid Connect Solar, which means inverter tech has come a long way in terms of ease of installation and user experience and all that sort of stuff. But because of the heavy commercial focus on Grid Connect and the costing around that, off-grid standalone battery-focused tech did not get the same love up until recently. And so what we set out to do there was to sort of tackle those problems that, historically it's been low voltage, lots of strings, lots of wiring, all those sort of things. It's just a bit of a nightmare to install, DC chargers. So we wanted to take sort of the same, or capture the same ease of installation that you have with a Grid Connect inverter, and bring that to off-grid. And that's what we did with the latest Gen CoolMax. So they're like high voltage strings, inbuilt earth fault, so you don't need any external earth fault detectors or anything like that. It's just goddamn easy to set up.
Yeah.
It's, the software we built for it is genuinely world class. Like it's it takes 2 minutes 30, I think, to commission a Coolmax. You plug in the USB, select your battery from the presets, hit apply, you're done. It's and it's going to get easier, right? The next iteration of the Coolmax is going to have Bluetooth on it. And it's going to be, it's a 2-second app process. So that's just making everything around it easier, right? Is kind of was the focus with this Coolmax gen.
Yeah.
Yeah.
So existing charge controllers, like you said, they were lower voltage, higher amperage input. So you've done a 600 volt input, which is our typical residential strings.
Yeah.
And so, forgive my ignorance, but how do you take 600 volt DC at around 12 amp and convert that into 48 volt 70 amp?
Silicon carbide.
Oh.
Yeah. So referring back to what we were talking about previously with leaps forward, this is only, the current generation Coolmax is only feasible because of significant advancements in switching technology. So we've been able to implement that in this new platform to actually step down high voltage into low voltage relatively efficiently. You could do it previously, but you'd need a heatsink the size of a house, basically, which is why it was never done. But yeah, through new silicon carbide tech, we're able to do it.
Oh, that's just so much more handy.
It's
a simple string.
It's good, and it's getting better too. Like it's the silicon carbide is going to change everything. It already is. Every EV charger is now being built on silicon carbide. It's going to underpin our energy mix entirely.
So we take that 48 volt DC, we DC couple that into a 48 volt battery.
Yep.
Of an off grid or sometimes even on grid hybrid system. Yep. What are the advantages of doing that?
Well, apart from a nicer efficiency mix, you're not double converting.
Right.
So with AC coupling came about because of the fact that there wasn't any good DC charging options between sort of 2000 and 2020. Right, that 20-year period. 2010 to 2020, that 10-year period, it was a 10-year period, there was just nothing that really allowed that easy installation process and provided a really good system mix. And so AC coupling came about to fill that gap, right? It was a sort of a Band-Aid solution, but effectively you're doing a double conversion, right? You're doing your PV to AC, AC back to DC to charge your batteries, and then DC back to AC on the other side when you need to use it. So it's really... What makes the most sense is looking at your load requirements, right, and sizing your AC and DC according to your daytime and nighttime loads, right? So if you've got this much battery for nighttime, you size that PV accordingly, and you DC couple that. And if you've got a high degree of AC loads during the day, you put some AC coupled PV on there. And the best mix tends to be a bit of a combination of both of them.
Yeah.
But the power going into your batteries, you want that coming from DC because one, it's more efficient, but two, it's actually better for the batteries. When you convert from AC to DC, you get quite a bit of ripple on there, which it creates a bit of heating in the cells. So just straight DC on there is a lot cleaner, a lot better for the longevity of the batteries. But yeah, and the other big thing is you can actually get around sizing regulations. So anything in terms of how much inverter you can put on there, it doesn't matter if it's DC coupled because it's behind the battery inverter.
So you've taken the wall mount, but you've also created a sleek little rack mount.
Yeah.
So what's the go with the rack?
So this comes back to the IT background, I guess, right? So there's something that the IT industry does incredibly well is serviceability. When you've got a data center with like 10,000 servers all racked in, right? How the hell does 1 or 2 people manage that? And this is a problem the industry is going to be facing over the next 5 to 10 years with all these products going into residential properties, distributed all over the place. How the hell do we service all that? It's going to be quite, when all these things start hitting end of life, it's just going to be flat stack. Or if you're a larger operation that's servicing or owning and maintaining their own assets, how the hell do you look after that cost effectively? So taking a leaf out of the IT industry space, we basically decided to, do something that's hot swappable, plug and play, and just makes it super easy to service. And this is it's the way I think off-grid really needs to go, because the reality is right now, if you have an installation that's 2,000 kilometers from the closest, wherever, the closest electrician, and there's an issue with the inverter, the charger, the batteries, or anything like that, you need to fly that person out there if it's really remote or it's a very long drive. And that's incredibly expensive to fly a qualified electrician
by
into the middle.
helicopter in the wet
That's
season.
right. It's crazy. But with a rack mount solution, right, and something that else we're doing, a connected rack mount solution, so remotely monitored, the service. If there's an issue with a module, it's a case of just ship out a new module. Someone on site can literally pull the old one out and put a new one in, and then restore the non-electrician, right? Because they're not wiring anything.
Yeah, right.
It's plugs in.
So you develop an actual chassis, like a rack chassis that it sits in.
Yeah.
And is it a typical 19-inch?
Yeah, it is. 2U
server
19 server rack.
2RU?
Fits in a lovely Power Plus cabinet.
Oh.
Yeah.
and two of your charge controller rack mounts fit into that.
Yes, it does.
So how much solar can you put on one of those?
You can put we allow up to 1.5 times oversizing on those. So you're looking at like bit over 5 kilowatts per module.
Okay.
Yeah.
That's quite a bit.
So you can have about 10 kilowatts of solar per rack.
On one.
Yeah.
And so could I just have infinite number of them?
Yeah,
Maybe
pretty.
not infinite,
I mean,
but
the only limitation is airflow, right? You need some cooling in there, but
Yes.
that is the only limitation, basically, and DC currents.
What does the back of it look like? Do you just parallel them up together? How does it work?
So a lot of the ones, it depends on the application. Basically, some people run massive DC or just DC copper bus bars up and down the back.
Yep.
Other people just do a link cable straight onto the existing Power Plus bus bar that's there,
Yep.
which works quite well.
Yep.
They're all internally fused, right? So it's safe to run them straight onto the DC bus.
Oh, that's great.
Which is nice. So it means you don't have to mess with, the only breakers you're dealing with the rack stuff is actually the PV isolation, which keeps it really simple. But yeah, basically either you cable onto a bus or you run a DC bus straight up and down the cabinet.
And these are what's in the Power Plus Escape series.
Yeah, that's right. So
Yeah.
they're powering the Escape series as well.
Yeah, right.
So question, I can see from your marketing, so you've really streamlined the programming part of things as well. You can daisy chain the charge controllers together, basically connect to the master, program it, and it will apply the settings to all of them. Now, in the event of a failure, yes, the charge controller is hot swappable, but how would the new module be programmed when a module is replaced?
Remotely. Yeah, so very shortly, very shortly, we're launching something called the AERL Nexus, which is our IoT gateway, basically, or energy management gateway, that basically allows you to remote into all these systems and configure them from anywhere. And that couples with another product we're launching called AERL Cloud, which allows you to monitor your distributed energy systems. So it's set up to basically have an organization within that, and then you can have all your sites all across the world connected in. And the Nexus has got 4G antennas, Wi-Fi, Ethernet, Starlink compatibility, everything, right? So there's the numerous ways you can connect in to make sure that the site's online. And it's one of those things that it's just so necessary for remote sites. You need to know what that system's doing, and you need to know if there's an issue.
So if I'm a Sparky in the field and I'm setting this whole system up and there's a problem with it, what's my point of contact with AERL for service or tech support? Do I call supply partners or do I call AERL?
You can call us.
Yeah?
Yeah. We 9 to 5. Some of the guys even 24/7 almost, but they'll pick up and help you through it.
Did you notice I stopped sweating when you said call you?
Yeah. That's it.
One less thing. Perfect.
Yeah. So no, look, we support our product through and through, and that's probably the biggest difference, I think, apart from the fact that the products are just nice, the biggest difference between us and some of the other players in the field at the moment, like the boys in blue, is that if you have a problem with their product, you got no one to call.
Yeah.
You call the distributor and hope for the best.
Mm-hmm.
And they're more resellers than distributors, right?
Yeah.
So with the AERL equipment, you can call the people that make it and manufacture it, and the way we have our support structure routed is that whoever picks up the phone will run through the basics with you, and then if you need more advanced assistance or it's a highly technical problem, we'll put you straight onto one of the engineers.
So what does your monitoring look like? Because this has become so important, not only for the end user to be able to see what their system's doing, but also for the installer and for you, the manufacturers. It's almost more important.
Yeah.
So that you guys can have alerts come up, you can see where the errors are, and wouldn't it be great if we could just fix a problem before the customer even knew it? So what is that looking like for you guys?
Oh, that's the whole idea behind it, right? Is we don't want the installer getting a phone call saying, "Hey, my power's out and I don't know why. Can you please come out here and help me?" The system is set up so that there is we can deploy firmware updates if needed to fix issues automatically, right? So it just we can just do that. And then there's an entire alerting system in there as well. Basically, that means that if there's an issue, you can set up rules and receivers. And basically, if genset alarm, no fuel, send text message to this person.
Oh, yeah, right on.
So, or AC voltage disappears, send an email or send a phone call.
Is this where the Nexus is going to come in handy?
Yeah, the Nexus facilitates that basically, right?
Yeah.
So it's the eyes and ears on site that's sort of talking back to the server.
So DC charge controllers have never really been able to DC couple into a managed battery before. So are you going to solve that with this?
Yes, absolutely. So the Nexus is also it's not just a remote energy management device, it's also the brain of the system. So that means it'll aggregate data from BMSs and things like that, allowing us to actually control and manage the full system. And the way that's going to look like over the next couple of months is you'll be able to install a Nexus with AERL equipment, any battery you like pretty much, and any inverter you like. And we're going to be pretty agnostic about that. So, pick your favorites, and then you can utilize all our everything in between.
That's so cool.
Yeah, and just circling back again, we were speaking the other day, and you were talking about that on one occasion you saw one of your systems out in the field had an issue, and I believe you jumped onto that and rectified it quite quickly. Now, at the time, I said I've never heard of a manufacturer doing that before, where they've found a product in their fleet that had an issue and took the initiative to go and rectify it. A lot of the time, people wait for a phone call to come through. Yeah, no. So we've got an automatic rectification system in place for Nexus connected devices. So if we get a hardware fault code or something like that come through, it automatically talks to our internal system. There's a couple of hardware fault codes that are, they're not recoverable. Talks to the internal system, automatically assigns a warranty replacement unit, ships it out, sends the installer a text message to say, "Hey, we've detected an issue on this site, a replacement is on its way, tracking number will be ETA'd at this date." See, you mentioned that so casually, but honestly, I'm just frothing. As someone who's been working in warranty for so long and it's so painful, that's amazing. So,
yeah, it's got to be that, and that works. That sort of system works the best with rack mount hardware, because it's just a simple fix at that point. It's pretty quick to swap over a wall mount, but a rack mount's even quicker.
Sure.
It's just a case of latch, pull out, put a new one in, done.
Oh man, the hot swappable's the way to go. I love it. It sounds so great.
Yeah, it's definitely.
And it allows for
approach.
modularity too, right?
Yeah, full redundancy, right? So the other thing too is if you've got just a whopping big inverter, right? That's a single point of failure.
Yeah.
Whereas if you've got a rack of modules, you'll only ever lose capacity. It's going to take, if you've got 20 inverter modules in there on a large site, you've got 20 points of failure before you actually lose AC.
Yeah.
So it just makes a lot more sense.
And that like if one failed, the customer would probably never know, and all of a sudden, a new little hot swappable inverter
Module
rolls up.
turns
and
up, right? Yeah.
with instructions on how to change it.
Yeah, that's it. And there's no issue there, right? It's just
I've lost power.
It's nothing catastrophic happens, and that's the way it should be, because power is critical, right? It's like it needs to be treated like a critical, critical application.
So what's next for AERL? What are you dropping at All Energy next week? I want to know.
Okay. So, Nexus is all the AERL. So Nexus, cloud, all the rack mount stuff and wall mount stuff you'll be able to see at All Energy. But we're also doing the next progression of that is we're launching something called XESS.
XESS.
Yes. So
Okay.
X Energy Storage Solutions, or
Okay.
XESS for short, or XS, web domain xs.energy.
No.
Full pun intended. So that is going to be the next iteration. So taking everything we've done with cloud, everything we've done with modularity, and creating something that takes the average off-grid install time down from days to just hours, excluding panels, obviously. But just takes the pain out of it.
And what is it? What does it look like? Or are you going to hold back?
I'm tempted to hold back. I'm
Okay.
tempted to say, come have a look at it at the XS booth at All Energy.
Yeah, that's a good call.
But it's exciting, and it changes
right.
it changes everything. Really does. It's a different approach.
That's so cool. That's awesome, man. I tell you what, your old man is smiling on you right now.
Hopefully.
No, he is for sure. You are doing some cool stuff. That's awesome.
Yeah, it's definitely been interesting. That's for sure.
Clearly, you're a very intelligent person, and some of that would have come through, I guess you've inherited it from your father, obviously. A lot of it you would have gained yourself. But who else has been a role model in your life besides your dad?
Oh, geez. Probably my mother, obviously. That's the mandatory.
Shout out to mom.
Shout out to mom. Yeah. She was the one that dived in and really genuinely tried to keep AERL running after Stuart passed away, and worked with Tritium to reverse engineer the IP. And
Wow.
I would not have been able to relaunch it in 2017 without what she did.
Yeah.
That was critical, right? It's otherwise I was starting from complete scratch in terms of design and things like that. I was able to. We didn't actually use much of the stuff, but I was able to actually look at it and understand it and reverse engineer what they did, and that's what actually taught me everything about power electronics.
Oh, cool.
So that's been huge. But just in terms of role models, anyone that's significantly engineering and technical focused and doing cool things.
Elon
Right?
Musk.
Yeah,
Yeah.
Muskie.
Yeah.
I saw on his Twitter today that their first human trials of the
Yeah,
brain chip.
Yeah, that's
the
going to be
Neuralink.
wild. That's crazy, right? It's going to be able to effectively Bluetooth spine.
Yeah.
Yeah, it's like
Unbelievable.
crazy, absolutely crazy. But yeah, those sort of people, right? Those Elon Musk, Peter Thiel, anyone that's done something significant in the last 10 to 15 years, I think, has definitely been an inspiration. And I've learnt a lot from watching what they do and reading about it, reading their books and things like that. Especially younger me, more so probably. 18, 19-year-old me really didn't have much of a clue to begin with. And it's sort of just, working out things as we went. But yeah.
You're so old now. I mean, it's just the future's dull.
I know. I'm on the wrong side of 25 now. It's all downhill.
Oh dear. Please don't say that.
No. Well, look, to be honest, the way that technology's going, we're all going to live to 150.
Oh yeah.
At minimum, right? If not more. That basically, I'm of the opinion that sort of the generations being born now will not die, provided we don't have some catastrophic ceasing of human civilization, right?
Right.
It's the way technology is going. It's going to be that way, and even classic UNSW is doing some really crazy stuff around reversing aging at the moment. they've been able to regrow the optic nerve in a mouse that they crushed. And they've also been able to regress a 80-year-old equivalent of an 80-year-old mouse to an 18-year-old mouse.
What?
Yeah, it's
Oh my gosh.
so it's what it's going to look like in 30 years' time is you probably every 10 years you take a pill and you go back a few years.
I'm glad I'm still alive.
Yeah, it's definitely looking at all we know about history. I'd say that the times we're living in now are definitely some of the most interesting times to be alive.
For sure.
And because of the rate of progression, right? And everyone says that it's like it feels like time's going faster and faster, and it is. Everything is speeding up. Everything, well, not maybe, but not probably literally, but society, technology, everything is speeding up because it's exponential. The better the technology we develop, the faster we develop things, and the faster things move.
Yeah.
And AI is going to do that as well. It's going to get crazy there too. It's we're already internally looking at design tools that basically cut development time down to zilch. What designing an inverter might look like in 10 years' time is, hello, Mr. AI, can you please design me a 10 kilowatt single phase inverter with a 1,000 volt input that's compliant to 62109-1 and -2 and meets these emission standards, and 5 minutes later it's done.
Generate the data sheet while you're at it.
Yeah, generate the data sheet
Sorry,
too.
marketing team.
Yeah, that's it. It's but that's genuinely where it's going to go to. And you think about how fast society is going to feel when everything is like this, right?
Man.
You think it's fast now, it's going to get faster, and it's going to be crazy.
My 16-year-old, he just turned 16, and we were making the decision on, okay, well, what kind of car do you want to learn on? And we have an old black stick Hilux here, and I was like, oh, you got to learn how to drive standard. My wife looks at me, and she's like, why?
Yeah.
These kids aren't even going to have to learn how to drive.
No.
Everything's going to be autonomous in 10 years. I was like, oh man, how fun does that sound? You just get to sit back and relax.
They're not even going to own cars, right? It's going to be press a button on the app and put in where you want to go, and
Totally.
The car's going to turn up and take you there, because which would be good for traffic. You think about it, there will be less than half the amount of cars on the road. There's going to be
some learning curves, but probably very, very low accident rates. It's almost like the Demolition Man with Stallone and Wesley Snipes, where all the cars just integrate into each other.
Yeah, well, that's it.
on
Merging onto a highway is just going to be like one after another, just
Thank goodness.
perfectly
God,
synchronized.
People are terrible at merging.
Yeah.
I heard a quote recently, and it was about the argument about self-driving cars.
Yeah.
And like the risks associated with that, and people have been giving Elon Musk some grief about that. Whenever there's news about a self-driving car being involved in an accident, everybody piles on and says how bad it is. This is the danger of self-driving cars.
There's a lot of vested interests in maintaining.
That's right. But I think overall the goal is when you look at this in 10 years' time or 15 years' time, is they want to bring the overall road toll down. Yeah. And they are already doing that. So,
yeah, absolutely. It's you look at the miles driven on autopilot now and the accident rate. It's lower than, I guarantee you, if you buy a Tesla and you have an accident in a Tesla, it's not because the car was driving. Yeah, it's because you weren't paying attention while you were driving. It's like,
Except for that one that was in front of your shop the other day.
Yeah. we won't talk about that. But yeah, no, genuinely, like it's incredibly, you've got something there that's paying attention at 100% the entire time. And our brain doesn't do that. We prioritize what information we take in, and we filter out everything else. And if you're tired in the morning and you haven't had your coffee yet, and you're late to work, and your phone's dinging on the passenger seat, you might have 20%, if at most, attention on the road. And that's just.
I love the hypocrisy of you can't be on a cell phone, but yet in our BYDs we have a screen.
Oh
big,
yeah,
and
I know.
Constantly putting on the next banger out, like the next song. You feel the wheel go, and you're like, shit, I'm almost off the road.
Well, up until recently, you could play solitaire in the Teslas while driving. They've now stopped that. But
that makes sense.
So they put the camera in the car, so the internal facing camera, basically to facilitate the self-driving stuff. And and shortly thereafter, the ability to play solitaire while driving disappeared. Because previously, all you had to do was say, yes, I'm a passenger, and play solitaire.
Oh, yeah.
And then I think they saw a lot of people saying they were passengers and playing solitaire while driving.
Well, we've gone fully off the rails.
Yeah, absolutely. But hey, it's fun.
But I think that's probably a great place to wrap this up anyways. How long have we been going? Probably about 45. Probably a good time. But Pete, yeah, man, thanks for your time. Thanks for coming in today, man.
Oh, it's
I
an
really
absolute pleasure.
appreciate it. We appreciate your drive, your ambition, your pursuit of innovation. It's really inspiring, and I appreciate you and thank you.
Thanks. Thanks for having me. It's always a
And
pleasure.
for those listening, to find AERL online, it's just aerl.com.au.
That's the
correct?
one. Yep.
Yes. And to purchase your products,
There's a company that does that. They're pretty good.
I had it here somewhere. Right.
Oh yeah, that
Supply
one.
Partners, yes. At any of our warehouses across
I
Australia.
know. How good. And XESS at All Energy. Make sure you come have a look. It'll change everything.
Absolutely.
It's
All
exciting.
energy. It's going to be a good time.
Looks awesome.
I'm looking forward to it. Thank you for listening. Until next time, enjoy the ride.